So welcome to another segment of my video, but this time I'm focusing on the potential divider rule. Remember last time we talked about resistors in series, but now I told you that there's a simple way of calculating the voltage across each of the resistors if the resistors are in series. Imagine that you connect a voltmeter, which we always connect across the component to be measured. So if you connect your voltmeter across the component to be measured, you have connected through resistor 1, therefore you are getting voltage 1. Across resistor 2, you are getting voltage 2. Now there's a simple way of you trying to get the voltages across the resistor when you know the total voltage. So the rule is simply called the potential divider rule. So you can use it when the resistors are in series like this. So for example, if I want to get the voltage across resistor 1, what you can simply do is that you can get the resistor 1 divided by the sum of the two resistors. So resistor 1 plus resistor 2, whatever you get, you multiply by the total voltage. That will give you the voltage across resistor 1. On the other hand, if I wanted to get to know the voltage, if I connected a voltmeter across resistor 2, I would have quickly known what the voltage is. I would say, what's the one you are calculating? It's resistor 2. So therefore, it is going to be resistor 2 over the addition of the two resistors in series, resistor 1 plus resistor 2. Whatever you get, you multiply by the total voltage. Now let me quickly take you back to the previous question that we did. Let's imagine that our resistor 1 there is equal to 10 ohms, and let's say that our resistor 2 is equal to 20 ohms, and let me say the total voltage from the source voltage total is equal to 12 volts. Here you have 12 volts, this guy is 10, and that guy is equal to 20. So how do you know the voltage across resistor 1? Like I said, you can apply the potential divider rule. So the potential V1 will be equal to resistor 1 you're finding, which is 10 over, then you add the 2, 10 plus 20, whatever you get, you multiply by the total voltage, which is 12 volts. So V1 will be equal to, that will be 10 over 10 plus that, 20, that will give you 30 multiplied by 12. Of course, if you notice, 10 there is 1, 10 there is 3, 3 there 1, 3 into 12 is a 4. So V1 is equal to 4 volts. And that's what we got even in our previous video when we looked at that question. What about the voltage across resistor 2? Well, the same. V2 will be equal to, you go to resistor 2. So this time it will be 20 over 10 plus 20. Whatever we get, we multiply by 12 volts. So V2 will be equal to 20 over 30 multiplied by 12 volts. Remember, this 0 and that 0 can cancel. I can have 3 there, 1, 3 there is 4, 4 times 2. Therefore, my V2 will be equal to 8 volts. So that's what we said. And when you add this and that, to be able to give you the total voltage. So this is what we call as being the potential divider rule. Let me quickly end by looking at a sample question that I chose from Examination Council of Zambia and see how you can go about that. So there's a question there that we can simply apply and practice on from what we have been doing. Study the circuit diagram below. When they put like this, it simply means maybe there are so many cells that are there, that's why. So it's 4 volts, 3 ohms, and 1 ohms. Then it says A, calculate the equivalent resistance. So they want you to calculate the equivalent or the total resistance. So the equivalent resistor, the total resistor, since they are just two, again, you can label your preference. Let me say R1, this is R2. That's my preference. If you want, you can start R1 and R2. It's up to you. So you can add R1 plus R2. So that is going to give me 3 plus 1, which is going to give me 4 ohms. So that is the total resistor that I'm having in the circuit. Okay, that is A Roman 1. Then A Roman 2 says the current through the battery. So the current through the battery is simply the total current. That's what the question is asking you to find. So apply Ohm's law. Current is equal to voltage divided by resistance. So the current, the total voltage is 4.0 divided by the total resistance, which is 4. Remember that is 4 volts and 4 ohms. Therefore, when you divide there, it is simply going to give you 1, or if you want 1.0 amps, or just 1 if you want, you can write. So basically, that is the way you can actually, answer that. Let's move on to the B part. We clear that and try to see how you can tackle that question. The B part, that's B Roman 1 says, how long would it take a charge of 2 coulombs to flow through the battery? So how long? So they're asking you for the time. So remember, time is equal to, in this case, charge divided by current. So it's coming, current is equal to charge divided by time. So this there, you just exchange the 2 there. So how long? So they have actually given us the charge. It is 2.0 coulombs. Do we know the current? In the previous question, we calculated the current was 1 amps. So therefore, the time that we are going to have is simply going to be 2 seconds. So it would only take 2 seconds for this charge to flow in the circuit. Okay, then we can move on to our last one, that is B2. How much energy would be used in moving this charge around the circuit? So they want you to find how much energy. Now you remember the formulas that I looked at for energy. You can apply many of them. For example, I can use energy is equal to voltage times what? Charge. Because I know the voltage from the battery is 0.4 volts, and the charge, I know 2.0 coulombs in that case. So when I multiply that, it is simply going to give us, in this case, if you want, 8.0 joules. Remember, energy is measured in joules. Well, this marks the end of my video. Thank you so much. See you in my next video as we look at, parallel resistors and how you can go about calculating them.